This is actually an academic research result, not only by me, but by my student there who could not join us, Ryan. So I just put his picture here, so he's with us somehow. And if you are interested in the results, the actual full results beyond the 10 minutes I was given, I suggest you look for Smart Oven over the internet. It's being peer-reviewed. And well, but Smart Oven, smart contracts, or otherwise you'll probably get a nice gadget for your kitchen. But yeah, Smart Oven is what I'm going to present here. So the whole motivation for the project is that smart contracts are great for flexibility. You can do many things of it on chain. And well, they are very interesting per se, but if you have a vulnerability, you go from flexibility to probably a disaster, like token theft, logical manipulation, data manipulation. So well, for all those that develop on smart contracts, be proud. Since 2021, we have OWASP top 10 common errors dedicated to us that make mistakes on developing smart contracts. So, and that's quite serious. Here are some numbers of the DeFi attack vectors that show how some vulnerabilities in smart contracts that have been developed, this is the number for 2024, how they affected attacks on chain. So, I mean, stolen private keys are still way more serious than that, but there are many of the top 10 here that are caused by vulnerabilities built in smart contracts that had not been checked enough for such bugs. So possible solutions for that, well, from the previous presentation, one solution is not having smart contracts on your chain. That also works. But if you do want some flexibility with smart contracts, you can do a few things. One of them is to go with training. I mean, better developers certainly are going to do better development and have less bugs on their smart contracts before they are deployed. The other very well adopted strategy in the whole ecosystem is to do some bug hunting programs that motivate developers to go there and find the bugs before they become really serious, preferably before they are fully deployed. And what we are going to talk about is automated tools. I mean, we can have, as in the regular development that has nothing to do with smart contracts, we can have interesting tools that evaluate the code and look for the bugs, and you can do that before you deploy. You have some dynamic analysis, static analysis. Today, many people are using AI to check code. And the question we want to answer is, which are the best tools to use, or a combination of those, and also which are the gaps that those tools still have, and so how can we develop better tools that close those gaps. And so the proposal by Ryan mostly is to build a database where we can compare the different tools in a fair manner, because I mean, even the output of those tools is different. The types of vulnerabilities they are good to catch are different. So how can we actually compare them scientifically, right? So academic project, we need to go with some method for that. And the method was to actually build with the so-called Smart Oven some database that allow those comparisons to be made fairly. So essentially, there are two sets of databases that are built there. It's based, the whole idea was kind of inspired by smart bugs that exist since 2020s. And the whole idea is to have a small database first that is manually developed and labeled, and with a good diversity in terms of which kind of bugs it displays. So those tools can test them and check for false positives, true positives, false negatives, true negatives. And also a huge database that is, in our case at least, it was collected directly from from actual chains. I mean, they are actual real-world contracts, and that can be in which we inserted some bugs, and then we can at least and label them. So the tools in that case we can match those labels to what the tools say that are actual bugs there, and see if they are actually correct. I mean, maybe some of those contracts also have bugs that we did not label because we did not develop those contracts. And so we cannot be sure that if there is a flag saying there is a bug there that is not labeled, if it's true or not. So we have to do some manual analysis also. But we also have a huge database that allows some automated analysis too. And with that, we started benchmarking the different tools that exist. This is the complete list of tools from the literature that we considered. There are many here, especially Mitral, the Solhint, and others. And we tested them for a few vulnerabilities. And here you can see a few of them. I'm not sure. Yeah, it's big enough. So some classical ones like reentrancy, some, well, classical from a perspective of the regular development, like overflows and underflows. And here's the thing. I mean, we tested more than 10 of them here. It's interesting to see that some vulnerabilities, no tool right now reach more than 50% of accuracy to catch them. Even though they are there. We are certain they are there. This is a small database. We inserted them manually. And so there are some gaps here to be filled. On the other hand, there are also some tools, especially Solhint, that get 100% of some interesting errors like reentrancy. And so, I mean, this is the result of the comparison. And here's not meant to be seen. Well, we actually can kind of see, but this is the result for the big database, a comparison with more of the vulnerabilities we could find in the literature beyond the top 10. And here is not meant to give a real comparison. It's just to highlight, again, there are some common vulnerabilities that have been seen on-chain for real that have not reached, no tool have reached even 50% of accuracy on those databases. So the Oscar goes to, if you want to check for each of those vulnerabilities, which tools are better. Here are them. Mostly Solhint does a great job. In some cases, you need Smart Check or Slither as the tools to go for that specific vulnerability. This is for the top 10, WASP top 10 specifically. Well, top 9 because we didn't consider front-running attacks as part of the analysis. And in the end, so the key takeaways. Probably if you are running, you are a developer, and you want to have some assurance that your code is not too bad, at least the main vulnerabilities are quite covered, you should go with a combination of Slither, Solhint, and Smart Check. Those cover well the main vulnerabilities, according to our analysis. Some are more updated than the others, specifically Slither and Mitral have a bigger database, developer database, so maybe this might change in the light of those results. I hope this change and those tools get better. And some things we are doing right now is to propose, find techniques to propose find techniques for detecting those vulnerabilities that are not well covered today. Also going with AI. We didn't test AI in this particular part of the presentation, the numbers I've shown you, like different AIs also, ChatGPT and DeepSeek and others, Claude. Also something important to consider is standardization. The tools, they give different tags for the vulnerabilities they find. So sometimes it's not hard to map one tool on the other. We did map for all the tools we consider here. But if new tools are developed, please consider the CWE for smart contracts, whose link is there. And the idea is also to spend this toolkit for the AI base, as I already said. And I'm right on time, so thank you very much for your attention.